Okay, so we'll do a couple quick examples utilizing this idea of power in its most simplest form. Remember, power is equal to the work per time. And we've also, of course, learned that work is the force and the dot product between force and displacement, which is often written as the force times the distance times the the displacement times the cosine of the angle, the magnitude of that displacement. All right, so here's the question. How much work can a 100-watt engine do in 30 seconds? So very straightforward. So a 100-watt engine, that's a power rating for an engine. So the power of the engine is 100 watts. Now we'll call it a purely efficient engine so that all of the engine rating goes into doing work. And so if we look at our relationship, power is equal to the work per time. We know that we have a 100-watt engine. It's asking how much work can be done. So again, straightforward, the work in 30 seconds. So we learn that the work is 3,000 joules of work can be done by a 100-watt engine in 30 seconds. All right, so pretty straightforward use of the power relationship. Let's try another one. So in this example, we're going to look at how much force is generated by a 100-watt engine motor when it moves an object 3 meters in 10 seconds. So you're looking at that power relationship a little bit differently. All right, so we still have our two relationships that we want to keep in mind, power and work per time, and what work really tells us. We want to know how much force is generated. Well, if we want to know how much force is generated, we need to know how much work that engine has done. So we'll start with the power relationship. So we know that power is work per time. We are told it's a 100-watt engine. Oh, I don't like to put that W in. Sorry, I'm not going to put the unit in there. It's a 100-watt engine. And how much work is accomplished by that in the 10 seconds that that engine is operating. So we know that we have 1,000 joules of work being done. Now, it's asking really about the amount of force that engine is applying to, and how much force is being generated to whatever object that engine is moving. And so we want to keep in mind that work is the force times the displacement times the cosine of the angle. Now, we're not provided any information about the application of that force, so we'll just look at that straight force where the cosine is 0, such that the force and the distance covered is in the same direction. So we can imagine that here's the object that the engine is in, and it's applying a force in this direction, and it's covering that 3 meters. So we have our 1,000-watt amount of work being done, force times 3, divide both sides by 3, and we get 333 newtons equals the force exerted by that engine. All right, so just utilizing the idea of power and the idea of work to solve some different types of problems. Good job.